This conference will now be recorded.
Hello, everyone. Brian Gockel here, Office of Observations. Welcome to the Satellite Book Club seminar series. Today's talk is going to be recent geostationary lightning mapper observations of bolides, bright flashes for meteors. Our presenter today is Joseph Patton, Faculty Research Assistant with CISESS, and our facilitator today is Jenny Pittman, the Sioux from NWS Topeka, and also acting STI Director for the Central Region Headquarters. As usual, the session's being recorded. A Q&A will be given, we'll take it after the presentation. Please put your questions and comments in the chat room. We'll field them from there. Most folks are already doing this. Please sign in with your full names so that we understand where the questions are coming from and can follow up with you later if needed. Check your spam folders if you're not receiving Satellite Book Club correspondence or TOWS correspondence that you're expecting. Occasionally, stuff is misdirected there. We look forward to future presenters and we welcome you. Please contact the TOWS team who could help you prepare a presentation and give a presentation yourself at a future seminar. Training team can help. Brian Mata can help with the development of training materials that you might need for such a presentation. Thanks as always to TOWS team, Kashad Bowman, Office of the Chief Learning Officer, GOZAR and JPSS programs, our facilitators, speakers, and all of you, our guests and participants. Just a few words to introduce Joseph. Joseph is a faculty research assistant with the Cooperative Institute for Satellite Earth System Studies at the University of Maryland, College Park, focusing on lightning research and training. His current position involves studying operational forecasting techniques using the Geostationary Lightning Mapper and creating training materials based on lightning information from the GLM for forecasters around the Western Hemisphere. Joseph graduated from the University of Oklahoma in 2015 with a BS in meteorology and Florida State a couple years later with an MS in meteorology. Served as an operation meteorologist with NWS for 2 years in Goodland, Kansas, before joining CISESS in the DC metro area. Joseph, welcome back to the Satellite Book Club.
Thank you so much for that introduction. I'm very happy to be back here. So with that, we'll go ahead and jump right in. So today we'll be talking about the bright flashes from meteors as seen by the GLM instruments. So we'll zoom into our first case here. So the first case I want to look at is from Oklahoma, from early in the morning in a January day earlier this year. So this event happened at around a little after 3:30 in the morning. So we had a dark night sky as the background. And I'll go ahead and let this video play. And the bolide in question is a bright flash seen in the sort of top center or center left of the video. And I'll let it play again. So this right here is our bolide event. And this is caused by a meteor which is exploding in the upper to mid atmosphere, and it releases a bright flash of light. And that bright flash of light occurrence is called a bolide. That bolide happens to often be at a wavelength, which is very similar to the wavelength that the GLMs are tuned for when looking for lightning strikes, which makes the GLM an accidental observer of all these bolide events. And this bolide was so bright that it was also seen not just in Oklahoma, but also in the neighboring states, Arkansas and Kansas. So let's jump into what this looked like in the GLM gridded products. So the first product we're going to show here is flash extent density, which is being overlaid with infrared satellite channel 13. And the flash extent density shows a small singular flash just southeast of Tulsa. If you look here, we're going to show a zoom in a second, but that's our singular flash, and that's our bolide event, is right here southeast of Tulsa. So zooming in and pulling in all three of the gridded products, we can see that we have in flash extent density in the top right, we have a small in area singular flash on the very low end of the FED scale. minimum flash area also shows that we have a small in area flash towards the very low end of the minimum flash area color bar. And then also for total optical energy, it's sort of a medium brightness. We got some pinks and then also some darker purples here. And it's showing some texture. So total optical energies can vary across the pixel. And recall here that the spatial resolution of the GLM instruments is 8 kilometers at nadir. So 8 kilometers by 8 kilometers means your smallest area pixel from the GLM is going to be 64 square kilometers, which is the bottom of the minimum flash area scale. And then that's mapped onto the 2x2 ABI grid, which is why we get some differences sometimes in our gridded products. But we can see from this example, we've got small FAD, a singular flash. We've got that 64 square kilometer minimum flash area, the smallest value on the scale. And then we've also got a medium brightness, so a textured brightness that kind of varies for total optical energy. So this particular event was well documented. Even though it happened early in the morning, the National Weather Service got several inquiries from the public as to what this event was. Anytime someone sees something in the sky, they think National Weather Service. So having these GLM observations is actually a really good way to share sort of a confirmation or at least a verification with the public that the GLM saw that this event was going on and that it likely was a bolide event, given that there weren't any sources of lightning that were in that vicinity. So the GLM data during these events can help ease that uncertainty in the public and act as a way, not only as an educational tool, but also as an authority to say that, yes, this happened and the GLM observed it, we know it's real, and it's probably just a bolide. So how common are these GLM detected bolides? Well, there's been nearly 2,000 of them just since the beginning of last year, since the beginning of 2022. This map here shows all those bolides in question since the end of 2021. And we see that in the gold color, sort of the darker yellow goes west on the west side, and the burnt orange color goes east on the east side. And then there's also an overlap region where that yellow color is, where we see bolides that were detected by both instruments. So that covers that overlap region between the goes east and goes west satellite, which is occurring really in the central United States and then into the eastern Pacific as we go southward. So this information is from a website run by NASA that shows all these bolide events as detected by the GLMs, and they collect this data and they determine with a certain level of confidence using machine learning whether or not these observations were likely from a bolide event or not. So the website is there. If you'd like to go check it out, you can look at any particular date and see where their machine learning technique has detected a bolide event, but it doesn't detect it doesn't necessarily bring up all the bolide events. So you may not necessarily find one in particular that you know happened on this particular website. But the link is there, neo-bolide.ndc.nasa.gov. And this website has more than just the maps. It can also show some really interesting information about the bolide as detected by the GLMs. So the first thing I want to show is that it actually, if you hover over the little dots, any of the dots on the website, it will show you the level of confidence, and it will show you whether it was detected by, or which GLM it was detected by, whether it was one or both. And then it'll also show you the duration of the event and the lat long and the time of the event. So it gives you a whole bunch of information here about how confident the machine learning technique is in finding the bolide. And it also shows you some interesting information showing you the different reported energies from the GLM as shown over time here. And we can see that there are several peaks here, right? There's a peak early and then a couple peaks here late. And that goes hand in hand with the video that we were showing earlier, where the bolide came across the screen and it was like flash, and then flash, flash. So that kind of repeated flashing can, in short succession like that can also be a good indicator that it's a bolide event. So this website shows the confidence, the duration, and the reported energy from these machine learning detected bolide events. So how about this bolide that we just looked at in the gridded products on January 20th earlier this year? Was that characteristic of how bolides typically look? Well, let's compare that to another bolide event. So this is a high-profile bolide case that happened earlier this year on February 15th in southern Texas. And the bolide in question is right up here in the top center of the video, moving from left to right. And this is in bright daylight. So it had to be an exceptionally bright event to be seen during the day like this. And that bolide occurred in the late afternoon / early evening hours. So there was plenty of sunlight, but also plenty of people to observe that it happened. So the National Weather Service office in Brownsville did an excellent job of showing that this bolide event was detected by, in fact, both GLMs, the GOES East and the GOES West GLM, and they showed flash extent density on here in their social media posts on Twitter. And they also mentioned that there was reports of that possible meteorite west of McAllen, Texas. So the National Weather Service, again, did a great job of posting this sort of verification of what they thought could be a bolide in the GOES East and GOES West GLM data. And that post certainly eased any uncertainty or confusion with the public in terms of what this event might be. And it also just serves as an educational tool of these are the kind of tools that scientists in the National Weather Service get to use to observe weather and other phenomena in the sky. So let's jump into the gridded products for this second bolide event, flash extent density. We can see, again, we have a small singular flash here. And this is from the GOES East or GOES 16 perspective. And this is being overlaid with IR satellite channel 13 to act as sort of a meteorological basis to make sure that, okay, there are no really cold cloud tops here, so this is probably not associated with lightning. It's probably some sort of artifact. And then you can piece together based on the reports that that was likely this bolide event. Shifting to minimum flash area, we can see that, again, we've got this gold minimum flash area value, color, which corresponds to a value very close to the lowest end of the minimum flash area scale, close to 64 square kilometers. And that is consistent, again, with the bolide that we saw earlier. And then finally, switching to total optical energy, we see a very similar case as before, where we've got a sort of medium amount of brightness overall. We've got some lighter pinks in here, which would be close to the middle of our scale. But then we also have some darker purples in here. So again, we have that sort of textured brightness from total optical energy, where it's not all uniform across the entire pixel here. So this event in particular was really high profile, not only because it was seen by quite a few people in southern Texas, but also because it actually resulted in a meteorite which made it all the way down to the surface. So this meteorite event was not only created a bolide, but also had enough material, enough mass sustained all the way to the ground to make an impact. And some scientists were able to figure out where it likely fell and actually recover the meteorite in question. So if you've never seen a meteorite on the ground before, that's what it looks like. It's quite a unique occurrence to see something like that. And so I wanted to include that picture here just to show you what it would look like when you find a meteorite intact at the surface like that. So shifting from those two particular events, which are included in this list, here are 6 different bolide events from about the last 6 or 7 months, and they all show a pretty uniform characteristic or set of characteristics from the GLM gridded products. And I also want to note that this the scaling does vary in these images, so they may not line up exactly in terms of size. But generally speaking, we can see that the flash extent density from these bolide events typically shows up as a single flash, which is blue in the standard flash extent density color bar. And then minimum flash area shows up as a small area. So that's the yellow or gold colors, the minimum flash area. And then total optical energy, again, across all these bolide events, tends to have a textured brightness where we've got some medium brightness and then also some darker brightness around the edges. So let's take that Southern Texas case and look more closely about what it looks like to see that case in stereo. So the top row here is flash extent density, or sorry, the top row here is FED, MFA, and total optical energy from the GOES East satellite. And the bottom row is the same 3 gridded products, but from the GOES West satellite. And right off the bat, we can see that there are a couple differences. First of all, the location is different. And second of all, the orientation of the pixel is different because of the viewing angle of the satellite. And then the biggest difference between the gridded product values themselves, FED and minimum flash area look pretty similar, but total optical energy is quite different between the two. We can see that the total optical energy for the GOES West satellite was quite dark in comparison to the lighter or brighter total optical energy from the GOES East satellite. And that can be attributed to the fact that this event occurred around 98 degrees west, which would be closer to the GOES East nadir, and therefore the GOES East satellite would have a better viewing angle for this particular event because it's a little bit closer. So that's not necessarily unexpected that the total optical energy would have a difference, but that flash was still observed by both the GOES 16 and the GOES 18 GLM. So because this event was captured by both of the GLM instruments, we can actually do some calculations. So this analysis is courtesy of Randy Longenbaugh at Sandia Labs. And essentially what we can do is we can re-navigate the observed Latin line of this event to a better triangulated position. So if we compare the GOES 18, which is in pink here, we can see that it was shifted to this from its original lat long on the left-hand side to its re-navigated lat long on the right-hand side. It was shifted to the south from 26.7 to 26.6, and it was also shifted to the west from 98.3 degrees to 98.6 degrees. And likewise with the GOES 16 observations, they were shifted also to the south, but then not to the west, but to the east. And so to see what that looks like, we can actually compare that with the gridded products here in the lower right-hand side. This is showing minimum flash area. So the GOES East is on the left-hand side, and it was shifted to the southeast, and the GOES West is on the right-hand side, and it was shifted to the southwest. So this ends up creating a sort of a triangulation where we can see the likely actual location of this bolide event, and having to shift these re-navigated lat longs corresponds well with what we'd expect from a standard parallax correction. So diving deeper into this analysis, we can also see that there was some interesting reported energy differences. This is being shown in the lower right-hand corner in that graph in the lower right. And GOES 18 in pink initially reported some greater energies from this bolide event than GOES 16. But as the event went on in time, GOES 16 or GOES East reported more intense and longer sustained brighter optical energy overall. And that, again, can be contributed to its better viewing angle for this particular event. So GOES 18 and GOES 16 reported altitudes of the flash at about 36.5 kilometers. That's in this center graph here. And that height, 36.5 kilometers, is definitely going to be more consistent with the greater height that we typically see bolides happen at in the atmosphere as opposed to lightning. But that's not to say that all lightning doesn't go up to that. We do have some transient luminous events that do happen at higher altitudes. But in this particular case, there weren't any storm systems in the area, and the GLM characteristics definitely suggest that this was a bolide event and not an actual observation of lightning. So one of the things that can be important when detecting or figuring out these bolide events is that auxiliary data sets such as radar or ABI imagery can be really good, reliable ways to verify that this particular flash from the GLM is not being seen, is not actually associated with something meteorological, such as a thunderstorm. So in this case, they act as a way to verify if the GLM flashes may be in fact artifacts such as bolides. One of the things I wanted to cover here is all the fantastic jobs done by people in the National Weather Service and in the broader GLM community when it comes to sharing these bolide events and helping to educate the public and ease some of the fears or uncertainty across the public. NWS Tulsa has done a really great job of sharing imagery from these bolide events as they happen. They've also happened to have quite a few of them this year. And there's the NWS Brownsville and also NWS Pittsburgh as well. And not only can this serve as a good way to share the science and educate the public, as is done in the top right with one of the GLM scientists, but it's also one of the ways where you can interact with the public and answer their questions directly. So definitely there's an interest here in terms of sharing those observations as a way to confirm that this event was seen by the GLM. And this image of the tweet from NWS Pittsburgh shares a good point, which is that even though a lot of the bolide events and many of the ones we see today were those single pixel events, not all GLM observations of these bolides will necessarily be single pixels. It depends on the brightness and the trajectory of the bolide, how long it lasts. In this particular case, we can see another bolide over Oklahoma in the center and left side that created sort of a Tetris zigzag shape. And then also the one shared by NWS Pittsburgh from early last year was extended through quite a few pixels of the GLM and had, again, our textured brightness from total optical energy. So in summary, bolides are frequently observed by both the GLMs, as many, almost 2,000 since the beginning of 2022. They often show up as low or singular FED, low or around 64 square kilometers minimum flash area, and medium or textured total optical energy. So additional context can be provided by the GOES ABI or radar or other auxiliary data sets to verify that this event was not meteorological. And then also stereo observations from both the GLMs can occur, especially over the central United States, in that right in the middle of that overlap region. And then finally, the last thing I want to share is that social media can be a powerful tool to share these observations, ease uncertainty with the public, and interact with the public when they have questions. So with that, I'd like to take any questions or comments.
All right, thanks so much, Joseph. I'd encourage everyone to stay on for the discussion. If you do have questions, please post those in the chat or indicate that you would like to ask a question. If you haven't signed in with your full name, be sure to indicate your full name within the chat when you are asking a question. Also, we're going to have a short survey that's posted in the chat box as well, so please take a few minutes to take that. A week from today, on Thursday, May 25th at 12 p.m. Eastern Time, we're excited to host Tim Walsh, who is the JPSS Program Director, and he will be giving an LEO program update. If you have questions about the Satellite Book Club or configuration of satellite products, please reach out to Kashad Bowman or Emily Maddox on the Tower S team, and they can help answer those questions. So let's move to some questions. We've got a couple here in chat. So the first one that I see is from Dan Lindsay asking if the VIIRS day-night band has ever captured a bolide.
That's an excellent question. Personally, I have not looked into the VIIRS data when it comes to bolides. I've been focusing solely on the GLMs here for this, but that would be something interesting to note. But Dan Lindsay does mention that it would seem highly unlikely given the infrequent passes and the relative rareness of bolides, and I think that's probably the right line of thinking there. One of the things that makes the GLM unique when it comes to observing bolides is that you have this broad geostationary continuous coverage, and that continuous coverage area always sort of looking, if you will, for bolides provides a unique way for the GLM to capture these events, these relatively rare events.
All right, thanks so much. Next question, does GLM catch any other kinds of flares from satellites, Starlink, that kind of thing? That's a question from Mike Stavish.
That's an excellent question. Occasionally the GLM will catch other stray light events. Sometimes the GLM will actually will actually perceive things like, I know one of the issues was seeing things like solar arrays on the ground. The light would flash off the solar array and back up to the instrument, and it would think it was lightning. But I haven't particularly seen a case where it would, where I knew it was coming from another satellite. But I imagine that those stray light cases where light reflecting off a satellite into the GLM does happen.
If I could add to that, Joseph, another example, the SpaceX explosion was observed by the GLM, and there have been a number of cases where it was likely another satellite rather than other space debris was bright enough between the GLM and Earth to produce a signal that did show up in the GLM data and had to be filtered out. So it is something, kind of anything that makes light bright enough for the GLM to observe, it will. And it'll be in the level 0 data. A lot of it's filtered out before it gets to level 2, but not all of it is.
Thank you, Scott. Appreciate that context.
All right. We don't have any additional questions within the chat. I was curious, especially for the case where you mapped both GOES 16 and GOES 18, the one that's shown up on the slide right now, that position that you ultimately came up with, is it pretty close to where they actually found the meteorite?
That is a good question. I now wish I had studied that more closely, but I know that it was found that there was an extensive search done, and that they were able to find it relatively quickly within a week or two. So I don't imagine it was that hard to find, but I did not check the exact location to cross-reference that with the renavigated lat one.
Okay, thanks. And I did notice that Mike Buchanan from NWS Brownsville mentioned that that tweet that they had nearly 1 million impressions. Oh, sorry, it's a Facebook post, but had nearly 1 million impressions talking about the bolide event. So that's really high. Let's see, Scott Lindstrom asks, was the parallax corrected data in Texas used to narrow the search? Oh, I guess I asked that already.
Yeah, that's a great question. Yeah, there's definitely a story there that's not part of this presentation as to how they actually went about finding it on the ground. But it'd be cool if we could get that story and they said something about the GLM.
Yeah, and Mike mentioned that they found it in Starr County. I'm not exactly sure where that corresponds to the X there, but mentioned that that's where it was found. All right. Well, I do not see any additional questions, so I will turn it back over to Brian.
All right, Jenny, thank you very much. I just want to do a double audio check here because I had a problem earlier. Am I coming across okay?
Yes, you're good.
Okay, great. Thanks, Jenny. Thank you very much for facilitating today. And Joseph, thanks for that presentation. I did have one question. It might have been answered, but I had an interruption here right in the middle of your talk. So if it was answered, my apologies. But I heard that there were some algorithms that could kind of determine based on other information that the bolide detection was a bolide and probably not lightning. What I didn't hear, and again, sorry if you said this, is are there any plans? Does anyone know? And I know Scott's on the line, others as well might be able to answer whether there are already plans to have that kind of QC flagged in the data so that a forecaster would know without having to use other independent judgment, if you will.
Yeah, the signals they make are distinct enough that you can flag them fairly easily. And when the data quality product is implemented, that's our intention, is to include an indication of that and the other types of events, like when the solar arrays cause reflections. So, but just wanted to add that not all of the signal gets through. So some of the data for these is filtered out. And so the folks that want to do the really accurate location, they go back to the level 0 data, and they can get very accurate locations and trajectories that they then use to kind of project it forward and backwards and look at the source region where it came from and use that for modeling studies. So yeah, it's some of the data is filtered out, and there's probably bolides that they find. I know there's bolides they find in the level 0 data that don't make it to level 2.
Very good. Thanks, Scott. Appreciate the work that you and others there are doing related to getting those quality flags in place and strengthening them for cases such as this. I'll make a last call for any final questions for Joseph or anyone else before we wrap it up.
I just wanted to make a quick comment that I did look up that location in Starr County, and it looks like that would be pretty close to where that renavigated lat lawn was that I showed with the minimum flash area product. So pretty cool that lines up with where they actually found the meteorite.
Very good. All right then, with that, I think we'll wrap it up. As Jenny told us, please come back a week from today. Tim Walsh is going to talk to us about plans for the Leo constellation, low Earth orbiting constellation, JPSS. We've got NOAA 21 coming online this year, and much more to report in that department. So come back next week. We'll hear what Tim has to say about that. Thanks to Joseph, to Jenny, and all of the participants. With that, we'll wrap up today's seminar and look forward to seeing you next time. Thank you.